In this section of Pre-Algebra 8.2, we're going to be discussing linear equations in two variables. A linear equation in two variables is an equation in which the variables appear in separate terms and neither contains an exponent other than one. So here are examples of linear terms and nonlinear terms. The first one, y is equal to 2x plus 4. That's a linear equation because the variables appear in separate terms and neither one contains an exponent other than 1. Now, 3xy is equal to 7 is not a linear equation. 5x squared plus y is equal to 6 is not a linear equation. A solution of an equation in x and y is an ordered pair that produces a true statement when the values of x and y are substituted into the equation. In lessons that we'll be studying later on in Chapter 8, you'll be asked questions when you're looking at a certain type of graph. Was it a productive year? Did they lose money? So graphs come in slopes come in four different forms, because these are the slopes of a graph. You either have a positive slope, which means it increased or it was a good year, which is A. B would be a negative slope. C is a slope of 0. And D is an undefined slope, which is no slope. We will go into this a little bit farther along in Chapter 8, but I just wanted to introduce you to the four different types of slopes. Now, a solution of an equation in x and y is an ordered pair xy that produces a statement when the values in x and y are substituted into an equation. So let's check these solutions, and we are asked to tell whether the ordered pair is a solution for this term, this equation right here. So 2x minus y is equal to 5. So we're going to substitute. And this is a solution, so all you would write is yes after you've shown your work. In B, when we substituted those values for x and y, it shows that B, the 4 and the 7, is not a solution for that equation. So finding solutions. Volcanoes. The Hawaiian volcano Mauna Loa has erupted many times. In 1859, the lava from the volcano traveled 32 miles to the Pacific Ocean at an average speed of 4 miles per hour. The lava's distance, d, in miles, from the ocean, t hours after it left the volcano, can be approximated by the equation d is equal to 32 minus 4t. The d is a distance. 32 is the total amount of distance from the volcano to the Pacific Ocean. And in the formula, we're going to say minus 4 times the time. T represents the time. So they're going to ask you to make a table of the solutions for the equation. If you recall yesterday, in our notes, I said we would start using a table similar to that. So in this, make a table of the solutions for the equation. Now I already have one written for you here, substituting. The t representing time, d representing the distance, and this is the equation that they've given for us to use. So we have substituted that in there. So if we substitute t for time, and the actual distance is equal to 32 minus 4 times 0, how much farther do they have to go if there was no time that passed? Well, that would be 32. Then, after 1 hour, if you substitute the 1 in there for that equation, after 1 hour, how much farther do they have to go? So there would be 28 miles left to travel after 1 hour. And then if you substituted 2 in for the formula, you would get 24. So the equation that they've given you is here in this column. Your T for time and your D is for the distance. So you could set this up in a table similar to this. So A, it asks us to make a table of the solutions for the equation. Now, from this table, you can see we have the X and the Y values, the ordered pairs. So we can set them up in ordered pairs. So my ordered pairs are 0, 32, 1, 28, 2, 24. So if you were asked to graph the distance and time, you would use these sets of ordered pairs to graph them. In B, how long did it take the lava to reach the ocean? You'll notice on B we set up the distance equals rate times time in order to determine how long did it take the lava to reach the oceans. So it took the lava about 8 hours to reach the ocean. So 8 hours was how long it took the lava to reach the ocean. And I just used this equation in B to be consistent with the equation that I had used in A. Now, the graph of an equation in two variables is a set of points in a coordinate plane that represent all the solutions of the equation. An equation whose graph is a line is called a linear equation. So for example, in example 3, we're going to graph a linear equation. Now, they have already given us the function. This is the function right here, and it says graph. Y is equal to 2x minus 1. So let's set up our table. And for teaching purposes right now, I'm going to use this set of numbers. Now, in order to determine, I can plug in what my X is, and then that will help me determine what my Y is. I chose those numbers because they're easier to compute. Now, if you have another function that asks you to graph it and it's in fractions, we're going to choose a certain amount, we'll choose certain numbers that will help us to solve that equation a lot easier. No matter what, if you're using this function right here, no matter what numbers you put in for X and get Y, it will be on the same line. Let me show you. So let's go ahead and solve this one. So I have the graph. Here's the equation right here. Y is equal to 2x minus 1. Y is equal to, now I'm going to substitute negative 2. 2 times negative 2 minus 1. Y is equal to negative 4 minus 1. So my Y would be 5. Next, I will substitute negative 1. This will be negative 2 minus 1 would be negative 3. I think I can do the next one mentally. 2 times 0 is 0. 0 minus 1 would be negative 1. I think I can do the rest of them mentally. 2 times 1 is 2. 2 minus 1 is 1. And the final example, 2 times 2 is 4. 4 minus 1 is 3. So this was A. We made a table of solutions. Now we're going to list the ordered pairs. So now we have listed the set of ordered pairs, which was B. Now we're asked to graph the ordered pairs and note that the points lie on a line. So I'm going to pause it and graph it, and we'll come back and check. So after we plotted those points for that function, we noticed it was a line, and it is a linear function. So in our practice problems, we're going to graph the equations, A and B. So you will start off by making your table. We can still use these numbers to be able to solve it easily. Oh goodness. For each one. And we'll come back and we will check our work. So here's the answer key. Okay, without that little hiccup that I had just a second ago, after I have graphed that function, and here is the table that it represents. So I'll pause it and I'll come back and show you B. Now notice in B, our table, the function was y is equal to negative x plus 3. Now, when you substituted x, your equation would have been y is equal to negative 2 plus 3. Or you could also say it is y is equal to the opposite of negative 2. And that would be 2. So 2 plus 3 is 5. And then again, and when you insert negative 1 where x is, that would be y is equal to the opposite of negative 1 plus 3. Then that would be 1 plus 3 is 4. And again, this is a linear function. So pay close attention to what the function is that they're giving you when you substitute the x. Okay, we have another example, so I'll pause this. We'll set up the table and let you check your work. So please check your work, and again, remember, when you substitute for x, be very careful with your sign and you plot it. Because this is a function, you will have and this is a linear function because this function right here makes a line. Okay, so now you'll have horizontal and vertical lines. The graph of the equation, y is equal to b, is a horizontal line through 0b. The graph of the equation, x is equal to a, is the vertical line, a, 0. This is not difficult. Watch this. Graphing, in example 4, graphing a horizontal vertical line. Graph y is equal to 3. So in A, so you'll notice on this graph, when y is equal to 3, you just plot it as if the x coordinate is 0, the y coordinate is 3. And you draw your line with 2 arrows at the end. We'll go to the next screen and we'll plot x is equal to negative 2. So on B, this will be considered a vertical line. X is equal to negative 2. You plot your point as if x is negative 2 and y is 0. And here is your vertical line. Now, we've been talking about equations and functions. And in previous examples 3 and 4, the vertical line test shows that y is equal to 2x minus 1 and y is equal to 3 are functions, while x is equal to negative 2 is not a function. A function whose graph is a non-vertical line is called a linear function. When the equation of a linear function is solved for y, the equation is in the function form. You may find it helpful to write an equation in function form before graphing it. So in this example, 3x plus y equals 7 is not a linear function. the function form of that would be y is equal to negative 3x plus 7. Isolating the y. So you took that same equation that was not a function, changed it into a function form. So in this example, write an equation in function form. Write x plus 2y equals 6 in function form. Then graph the equation. To write the equation in function form, solve for y. So since this is not considered a function, we are going to subtract x from each side. So now we have 2y is equal to 6 minus x. Next, we'll divide each side by 2. Y is equal to 3 minus 1/2 x. And then putting it in proper order, now we have set it up now as a function, and it will be a linear function, as we said at the beginning of the lesson. Now that you have seen the equation now as a function, I'm going to pause the video. We are going to determine what our domain and range will be. Now in this example, example 5, I'm only going to use even number values so that the y values are integers. This makes the ordered pairs of x and y easier to graph. So be sure to choose convenient x values when you graph an equation. You remember in the previous examples we were using -2, -1, 0, 1, and 2. But I changed that because these would be easier to graph. So I'm going to pause it, graph it, and you can come back and check your work. Note that the table that I have here, it forms a line. So this is considered a linear function. In plotting this in previous examples, when you graph y is equal to -1, and you're graphing horizontal and vertical lines, your x is 0. And in this case, your y would be -1. And then when you're asked to graph something that looks like x is equal to 4, then your y will equal 0. So you plot those ordered pairs, and then you draw a line through those points. I'm going to do that and come back and check. And here is your answer for those two graphings. Y is equal to -1 for the horizontal line. X is equal to 4, the vertical line. So the last example, write 2x minus 3y is equal to 3 in function forms, then graph the equation. We'll come back and check our work. So notice in blue, I took our original function, our original equation, and needed to change it into a function form. So I subtracted 2x from each side, which left me with -3y is equal to 3 minus 2x. Then again, in order to isolate the variable, I needed to divide each side by -3. In doing that, I'm left now with y is equal to -1 plus 2/3 x. Because 3 divided by -3 is -1. The -2 divided by -3 is going to be -2/3 x. Then I'm going to put it in the appropriate order with my variable first. So I put y is equal to 2/3 x minus 1. Then, again, because I wanted to be able to graph it with integers, I selected something that would be easy for me to be able to use that function with. So I chose numbers that would help me to be able to solve it easily and graph it. But again, since it's a function, and you use this equation right here, no matter what number you put in there for x, it will be on this line right here.